slide where you showed the unsharp aspect.
For verbal?
Yeah, the first one. And before you get there, ask a second question. I wonder how you do fitting the kinematics and style population together, because I'm concerned about degeneracies in the solution. I mean,
So the point is that when you feed them together, you get rid of degeneracy. If you feed them separately, your results are actually.
You're adding more parameters.
Yeah, but it's just 2 parameters more. You have A, velocity, velocity dispersion, and velocity instead of. And you know, this is much better than trying to put the stellar templates inside and to mismatch the metallicity, which actually which would produce biased values of velocity dispersions. It's published with this, and there's a thorough check of all the degeneracy effects. So I can give you the reference. I can give you references to.
So the first row is the same galaxy?
Yeah, the first row is the same galaxy. Here's just unsharp masking, and here's the subtraction of the symmetric model, just to enhance the spiral arms. You know, this was the technique by Bingeli, Jurgen Bingeli in 2002 when they discovered the first spiral in IC3318. This is CA56.
Can you trust this sort of inner bar that appears in the disclosure?
Well, you know, this is just it doesn't mean that this is a real bar, but this is what you get when you subtract the symmetric model. The point is that here, if you just fit elliptical isofolds, you probably will get rid of spirals immediately. It's like in many spiral galaxies. You know, if you vary position angle and ellipticity, you may fit quite well the grand design spiral, leaving no spiral weight. In order to enhance the spiral, you really need to subtract the smooth distribution. Smooth light distribution. No, I'm sure. I'm sure that this is too small. I mean, this has to be clearly checked, carefully checked. But this galaxy, I think, has been observed. This has been observed with the ACS. So there, I can check this. This is the data from 2006. This picture.
How many of them have bars instead of what fraction?
All this I cannot answer because, you know, presently we're dealing with 1, 2, 3, 4. You know, in the Virgo cluster we have only about 40 galaxies, 45 galaxies which exhibit, which have definite disk, probable disks, or possible disk, in the following the terminology of Torsten. From those certain disks, there are only 14. Of course, this was done using the preliminary version. Well, it was DR5 of Snow, so there were still holes in the coverage in the footprint of the Virgo cluster. Have bars, at least a third from the brightest. Well, first of all, I would like to say that there are very few dwarf ellipticals in the field known at present. I don't recall any galaxies in the field with disks, but there are dwarf ellipticals with disks in groups. There is NGC 770, it's a dwarf elliptical with a counter-rotating disk, embedded disk. And it's a satellite of a large spiral NGC 772, and this is one of the examples. But for the field galaxies, well, usually you don't observe dwarf ellipticals, and my personal opinion is that if you find a dwarf elliptical in the field, it's a galaxy which is ejected from the cluster.